ॐ भूर्भुवस्वः तत्सवितुर्वरेण्यं भर्गो देवस्य धीमहि धियो यो नः प्रचोदयात्.
The first program on Java, we are going to assume that you have already connected to the cloud, which I am assuming all of you by now know how to connect to the cloud, and we have a directory on the cloud called OOP class. Written OOP is small, C is uppercase, class. This directory will have you will have access to this directory. This is under root. So this directory will contain all the exercises which you have done. Now while I am saying you have access to this directory, you will be able to copy the programs from here, but you will not be able to change the programs in this directory. So that is how we will work with OOP class. So we will have permissions to alter this class, but the students will not have permission to alter anything in this class. Okay. So today we are going to start very simply by creating a Java class and then showing you how to execute that Java class. So we will be creating two files today, one a class file, and basically both will be class files, but one will be an executable class file and the other will be just a class file. So we are going to understand also the difference between executable classes and non-executable classes. So let's start in a very simple manner. Now in Java, whatever you create has to be a class, whether executable or non-executable. Everything in Java is a class. In a way, it is superior to C++ because in C++ there is no mandatory requirement that things have to be a class. So given that, we will first see how to create a Java class and how to then get it to execute. Now, as we have talked about earlier, a class is a real world entity. So let's take a common example of a class which we normally do, which is a subscriber. A telephone subscriber is our first class that we are going to study. So when we talk about this class, a class has state and class has behavior. So if you say a class subscriber, he has a state. What is the state of a subscriber class? His name, his phone number, his age. These are all different kinds of data about a class. This is called the state of the class subscriber. Does he have operations? Yes, he has operations. He can make a call. He can, using a subscriber class, I can make a call. So make call is a method on a subscriber class. He can receive a call. He can basically do things like he can pay a bill. He can do things like he can receive an SMS, send an SMS. But let's talk about that later. Let's first create a fundamental class using our VI editor. Remember, we are on a cloud. We are logged into the cloud. We are in a directory called OOP class, and we are going to create a small class called subscriber. Then we are going to worry about its instantiation and execution. We are going to go through one quick program step by step. So what did we say here? We said vi subscriber.java. Now that's a file we are going to create. We have not created it. So this is a file we are going to create. Also pay a small attention. It is convention in Java to name the class name with an uppercase first letter. So when he created the file subscriber.java, there also he took the care that he called the file with S as uppercase. This is not mandatory, but this is one of the good habits of Java programming. So now, how do we start? Now we are going to start, as I said, in Java, everything is a class. So I'm going to start creating class subscriber. So we're going to say CLAS class, and so class is a keyword, and subscriber is the name of that class. So we're going to say class subscriber. This is how we start. Now, as I said before, the name of the class has to be descriptive and has to start with an uppercase. Will something go wrong if I start with a lowercase? No, but you'll break the basic programming habits which you need to build which is having name of the class as an uppercase. The first letter should be uppercase. So I have defined class subscriber. Then after that we start with an open bracket, open brace. So that is compulsory. That starts the definition of a class. First, as per convention, we describe the state of the class with its individual data types. So let's talk about the data types in class subscriber. So what are the data types? What all do we want to represent in a subscriber? About the state we want to represent his name, his age, and his mobile number. So let's use various primitive data types and various data types to represent the state. Let's start with age. What kind of age it will be? Age can be represented either as a byte field or it can be represented as an int field. Now we expect that the age will not be more than 100 years. I don't know of any subscribers who have lived beyond, too many subscribers who have lived beyond 100 years. But let's use a byte. Let's use a byte to represent a age. Why am I using a byte? Because byte can have values up to 256 or if it is a signed byte, then its value is lesser. So let's keep byte as age. Okay, we're taking a little risk that we may not be able to contain very old people, really old people, but let's live with it. So because byte takes for me only 8 characters, 8 bits, which saves a little bit of memory for me. So I'm putting age as byte. If there are any consequence of that, we'll see that later. Now, what is the next thing which we want to represent? Name. Now, normally in C programs, we don't have a string data type. But languages like Java are a little more advanced. They have a string data type. Now, so string is a predefined class which is available to Java programmers. So we say string name. Now, let's spend a little time looking at these two lines. So when we said age, we use byte. Byte is called a primitive, whereas string is a predefined class provided by the Java language. So when we are saying age is of type byte, we are saying age is of a type primitive called byte. Byte is a primitive. Other examples of primitive are long, short, int, char. These are all primitives. We'll talk a little more about primitives as we go. When we talk about name, we are saying name is of type string class. So name is a reference to a string class. Remember, in Java, we never use pointers. There is no pointers. So we say name is a reference to a string. Byte is of, age is of type byte. That is what it would mean. So, and this would have some interesting implications a little down the line. And then we have MDN. MDN means the mobile device number. Now, mobile device numbers are typically 10 digits, or sometimes there is a proposal even to make it 11 digits. 11-digit value may not be possible to hold in an int, so I am going to use a long. So I am saying long MDN. So mobile device number is long. Now these three fields are used to represent the state of subscriber or the data in subscriber. So there are three fields. There is age, there is name, and MDN. From a classic object-oriented point of view, we call them as member data, or we call them as state. So the state of a class can be very big, and each of the objects of this class are automatically going to have this state. That much memory is going to be allocated for every object of class. Please remember, class is always a blueprint. Class does not take any memory. Class is only a blueprint. Like for every apartment, when you create, there is a blueprint for the apartment. Does blueprint take any space? No. Blueprint is only a design. It's only a strategy. It's only an idea. And what comes out of it is the apartment, which is an instantiation of a blueprint. Does an apartment take space? Yes. Does it cost money? Yes. Does it have area? Yes. So basically, that is what is the difference between an object and a class. Here what are we defining? We are defining a class. So is it going to take memory just yet? No. As of now, no. But when we instantiate it, memory will be created. How much memory? Big enough to hold age, name, and MDN with that data types. Okay. Now we are going to add some behavior. In object orientation, Behavior means verbs, means the various kinds of operations which can be done on a subscriber. Let's define some very basic behavior like make a call and receive a call. That is a basic behavior from a subscriber. So we say void make a call. Make a call. Make call. Let's not say make a call, make call. Okay. Now, let's stand back a little and see what has been achieved as yet. When we said make call, that is an operation. How do we identify operation? By these parentheses. Okay. So braces are used to start a class, start a method, all that. Parentheses are for holding parameters. So when I say right now make call does not take any parameters. But if make call was supposed to take any parameters, those parameters would be part of the make call. I would give the parameters here. In some of our later methods, we will actually have parameters along with the data types in the parenthesis. And what does void mean? Void means, does make call return anything to the caller? Whoever is invoking make call, does he get anything back from make call? The answer is no. He doesn't get anything back from make call. That is why we have void. Void is a return data type. When we say make call is not going to give back anything, make call is going to do something, but it's not going to return any value to the caller of make call, we are saying a void. We are giving a void, thus indicating to the programmer and to the compiler that make call is not expected to return anything. The moment I put a return, then make call will have to have a return data type. So in make call, let's write some dummy stuff here. We'll just say system.out.println, and I'll elaborate a little bit on that also. Println. We're just going to put some code there like this, which is make call called. I mean just to tell the user that something happened. That's not doing anything. It's a dummy. Okay. So we'll close the method. Okay. Now let's look at the body of the method. So this is the declaration of the method and this is the body of the method. What is there in the body of the method? We want to print a message on the console called make call called. That's it. Now how are we doing it? Look at this. There is a predefined class provided by Java. That means when I say Java, by the environment, by the Java virtual machine, that predefined class is always available called system. There is a predefined class. In that class system, there is an object. This OUT is an object. Normally we call it a static object which is available all the time. So system is a predefined class. It contains an object called out. Please understand, the out object is sitting in a class system. Now out is not an instance of system, it's a class, it's an object which is part of system. Okay, so this object out normally refers to console. That means if I want to do anything with the console, I use the out object. Whatever I do on the out object, that will appear on the console. Now this out object has some methods. What are the methods? Print line, that is one of the methods. So print line is a method available in the out object which is part of the system class. Later we'll say what is this system class, what is this out object, we'll study that at length later. But at this stage, just believe us or believe me when I say there is a predefined class called system. In that, sitting inside that class, there is an object called out. On that out object, different kinds of operations can be done. One of the operations which can be done is print line. And what is this string? It is just like a string which has to be in double quotes, which has to be given to print line. Print line always takes a string and prints it on the screen. Print line can do other things also. But at this stage we are asking print line, please take this string which is make call called and dump it on the screen. Okay. So we have a dummy make call. What is make call going to do? What is make call actually? Make call is a method. Does it take any parameters? Answer is no, because I don't have anything in this parenthesis. Does make call return anything to the caller of this method? No, because we have a void there. And then does the body of make call do anything? Well, really not anything significant except printing a message on the console. Why does it print a message on the console? Because of this. System is a predefined class. It has an object called out sitting in system. On that object I am invoking a method called print line. And what is that print line method doing? It is printing make call call. What is this use of this brackets? Is to end this method. Okay. So let's write in a similar manner another method called receive a call. We'll say void receive call. Okay. There is one more small thing which I would like to point out. Look at the way he is giving the names for the methods. The way he is giving names for the methods is he is making the first letter small, and whenever the word, a different word is used, see make call, there are two words here. Make is written in lowercase, but the C of the second word is written in uppercase. That is called a camel notation because it looks like a camel's back. The first letter, when the method name consists of more than one words internally, the convention is the first letter should be lowercase of the first word. The first word of the first letter of any other word in the name of the method should be uppercase. So if you see now, he is using the same logic in a consistent manner. Even here he is having receive call. So what is receive call? It is again having two words, receive and call. The first word began with a lowercase, the second word began with a uppercase. That is why we have C as uppercase. What are we going to do in receive call? Again we are not going to do much. We are just going to print system.out.println. Same thing, only thing is the body of the string is going to be different. So we'll say receive call called. Okay. So here is our first level class. What is there in this class? There is a name to that class and that keyword class. There are three states of this class. One is two are of type primitive like age and MDN. Name is of type another class which is string, which is, as I said before, it's given already by the Java environment. There are two behaviors or methods in this Java class which is called make call and receive call. In object orientation, every class consists of a state and behavior. Every non-executable class generally consists of a state and behavior, even executable class. But there is a specific behavior which is expected from an executable class. We'll come to that. So basically we have a class subscriber. So what we are going to do is we are going to say right quit on this class subscriber. Yeah, we must not forget to close this bracket with this bracket over here. Basically because if we close those brackets, we are saying we are ending this class. So inside this class there are two methods which are started here, ended here, started here, ended here, and the whole class has been terminated with a bracket, and that is where we are ending. So we are closing this file, we are saving this file and then coming out. Okay. So we are back at the dollar prompt. What have we created? We have created a file called subscriber.java. Can we compile this file? Oh yes. How do you compile a Java class file? You say javac. So let's say javac on it. Yeah. So let's say that. And we didn't get any compilation errors. Now if I do an ls minus l on subscriber, okay, now I have, as you can see, two classes. Okay, one is subscriber.class and subscriber.java. Now the time you might see is a little different from the time in India. The time in India, as per the watch I have with me, is about 11:15, and the time it is showing is the midnight of December 22nd. That is, December 22nd has just begun, and the time is midnight of 48. That is, it is 12:45 in the night over there. The reason is that is a time for the Linux instance when it has been where it is residing. So depending upon where it is residing, we get the time of that time zone. So please don't get confused about this time, because this time is not the Indian time, because we are running on a cloud. The time is as of the US time zone. So they are about 10 and a half, or 11 and a half hours, I think, behind us in terms of time. You could calculate that. So based on that, you can figure out the time zone in which the Amazon cloud is running. So let's keep it that way. So please don't get confused about the time. But the important point to understand is, now in my directory there are two files, subscriber.java which I created and subscriber.class which the compiler created. So I have these two files. Now before we start working with the subscriber.class, let's do a few tricks and then come back. So having created a class and compiled it, now we have two files with us, subscriber.class and subscriber.java. Now what we are going to do is, let's just give subscriber.class, let's try this. Let's give subscriber.class to the virtual machine and see what does the virtual machine have to say about subscriber.class. Meaning, what we will do is, we'll say as we saw in the last class, Java subscriber. Okay. Now, something interesting is going to happen when I say Java subscriber. You know what? The Java virtual machine is going to look for subscriber.class file that it is going to find, because we have already created subscriber.class. But you know, an interesting problem which is going to come up is that though it finds subscriber.class, our subscriber.class, if you really see, is not an executable class. Now you'll ask, what is an executable class? A class which has a main method is called an executable class. What is happening today or right now is that though we have created subscriber.class, it doesn't happen to have a main method. And if a class has to be executed by the JVM, it needs a main method, and it's not finding a main method. And then so it's like saying, though you have a subscriber class, the JVM doesn't know what to do with that subscriber class, because it doesn't know that there is a main method, or it doesn't find a main method. And let's see what kind of error the Java virtual machine which is getting invoked here is going to throw up. As expected, it is throwing up an error, no suitable method main in class. That is expected, because you know the JVM doesn't execute until it finds a main method. So though we have created a class, our class is not deemed as an executable class because it does not have a main method. What does our class have? It has two methods. One is called make call, other is called receive call. None of these are main methods, and which is what JVM is finding. So are we going to go and change our subscriber class? No, we are not going to do that, though that is feasible. We can add a main method to a subscriber class and get it to execute, but that would not be a right thing. What we are going to do instead? We are going to create a test class which is going to have a main method. So let's start with a test class. So we are going to say vi test.java. Okay, or let's not call it test.java, let's remove that file. Okay, we'll call it, let's follow a convention, we'll say test subscriber.java. So vi test subscriber.java. So it is going to be a class which is going to test subscriber files. So we have this class called test subscriber.java. This is the class we have created. Now let's work with this class in order to understand how do we create a class with a main method. So we say class test subscriber. This is a class we are creating. It's going to be an executable class. Okay, so we have class test subscriber. Now what are we going to have here? Is it going to have a state and a behavior? Well, potentially it can have a state and a behavior, but what we are going to do, we are not going to put any state or behavior in this class. Instead, the only method we are going to have in this class, we are going to have some behavior. Which is that behavior? Which is going to be the main method. So this class is going to have just one method called main. Okay, let's write the main method. Okay, let's write it the way he is writing it. Okay, now let's write the proper signature for the main method. Okay, now let's spend some time looking at this main method. Now I'm not going to at this stage talk about all the attributes of the main method or all the declarations for the main method. Sometimes these declarations are called modifiers. The modifiers associated with the main method are public and static. Only thing right now understand is the main method which we are going to look for, or which the JVM is going to look for in this class test subscriber, needs to, if it is to be executable, it needs to have two modifiers. What are the two modifiers? It has to have a modifier public and it has to have a modifier static. we'll come back to it. Why does it need two modifiers, public and static? Okay. The other condition on the main methods are that the main method shouldn't return anything at all. It should basically have a void return. We saw this void return in make call and receive call also. That is, the main method also should not return anything to the JVM. Remember, the main method is not going to be called by us. The main method is going to be called by the JVM. So it is not going to return anything. That is compulsory. So the signature of the main method is, it is not going to return anything, and it is going to accept an array of strings. If you see this, args is a parameter. What type of parameter it is? It's an array of strings. So the main method, we are understanding, has to have certain well-defined modifiers and certain well-defined signature. What are the modifiers associated with the main method? They have to be public and static. At this stage, we are not ready to get into the discussion of why public, why static, all that discussion let's not get into. Only let us understand that there needs to be a declaration public and static, that these two modifiers need to be there. The main should not return anything so that there is a void, and also the main method, it should not be written in uppercase, it should be written just like any other main method, and this is also compulsory. What is compulsory? The main method should accept an array of strings as a parameter. If you don't like the word args, you can use some other thing. That is just like a formal parameter. This is, the word args can be arg, word can be sa, that the Java compiler doesn't care, as long as the data type of this parameter is important, which has to be an array of strings. How did I make it an array of strings? I said string, and I defined these square brackets, which makes it an array of string. There need not be a space also between these two, then also it is fine. Okay. So you can define array two ways in Java. We'll come back to that. So at this stage, just have faith in me and say that this is the main method which we are going to have with the appropriate modifiers, appropriate return type, and appropriate signature. So let's write a main method, and please be very clear. Why are we writing this main method? So that our Java class, which is test subscriber, is an executable class. Because when we tried to execute subscriber.java, the JVM told us you can't execute it for the simple reason that there is no main method. It said, I cannot find a main method here. So we are giving a main method with an appropriate signature. Now what we are going to do? Now remember, we already have a class called subscriber, which has been compiled and ready and waiting for us. Okay. Now this is a class. Remember, in Java, certain classes can be used just as it is. But what is the normal way of using a class? We create an object of that class. So now we need to instantiate subscriber class. How do we instantiate subscriber class? It is normally a two-step process. Let's declare a reference to subscriber. So we are going to create a reference to subscriber. So we are going to say subscriber S. Now please understand what's happening here. Let's sit back a little and understand. Whenever a program executes, as we know from basic programming, whenever a program is executing, the operating system, or in this case, the Java virtual machine, is going to create a stack. So there is going to be a stack. So whenever this program is executing, a stack is automatically going to get created. How big is the stack? That is not important right now. Stack may be 4K in size, 8K in size, or bigger than that. A stack is getting created. So when I create a variable S of type subscriber, you know what is happening? In Java, we don't have pointers. We're just saying S is a refers to a subscriber. Means what? S is going to be used to hold an address of a subscriber object. Please, let's understand this once again. What are we saying? Whenever a program executes, a stack is created. Second point we are saying is that if you look at the line subscriber S, we are declaring S as a reference to subscriber object. Meaning what? S will be used to hold the address of a subscriber object. Has a subscriber object been created? No. We just have a subscriber class. But now we are creating a reference. A reference is S, which is of type subscriber, or which is a reference to subscriber class. So please understand, internally we are saying S is an address, S is a pointer. But in Java we don't use the word pointer, we use the word reference. Internally, S is treated as a reference to a potentially going to be created subscriber object. The subscriber object is not created. We are only saying S is an address of a subscriber object or a reference to a subscriber object. So at this stage, what happens is S gets allocated. S gets allocated on the stack. S is allocated on the stack. What does S contain? S contains a null. At this stage, S is containing a null because S is not pointing anywhere. We have just defined S. S is a reference. S is going to be used as an address. But right now the value of the address is null. So S is created on the stack. Memory is allocated for the stack. It is not important to understand how much memory S is taking. It is taking memory good enough to hold a address. Is there an address there? No. At this stage it is null. So if I try to do anything on S, it will give a null pointer exception or a null reference exception. But we are not going to go into that exception yet. So please understand, S is like a pointer, but we don't call it a pointer. S is an address. Where is that address sitting? Address is sitting on the stack. What is the value in that address right now? Null. Now, what are we going to do? We are going to create or instantiate a subscriber object. In order to instantiate a subscriber object, what do you need? Subscriber class. In order to create an apartment, we need a blueprint. In order to create a bucket, we need the mold for the bucket. The mold for the bucket is like a class. Then we pour plastic on it and get our object. So we need a better idea is think of a blueprint. We have the subscriber blueprint, but we have not created an apartment building out of that blueprint. Now we are going to instantiate. Which is the operator in Java which is used to instantiate a subscriber object from a subscriber class or an object from a class? The operator is called new. There is a new operator. This is a keyword of the Java language. What does this operator do? It is used to instantiate a class and result in an object. Normally, where are objects created? Not normally, almost always. Where are objects created? The objects are never created on stack. The objects are created in heap. So using new, an object can be taken birth on the heap, and the reference to that object can be in a stack. So now let's write a very powerful line. We'll say line 6, S is equal to new subscriber. Okay, we said S is equal to new subscriber. Now let's ponder over it for a few minutes and then proceed. So we are saying new subscriber is a mechanism. Subscriber is a class. When I say new subscriber with a parenthesis, we are invoking what is called as a constructor. We'll not talk about constructor. Let's understand only this at this stage. We are saying new subscriber. When we say new subscriber, what are we doing? We are instantiating a subscriber object. Where is this object taking birth? It is taking birth on the stack. So imagine a new object big enough to hold age, name and MDN. All of that are in this object that is getting created. Where did it get created? On the stack. So we have two memories. It got created on the heap. So we have stack and we have heap. So an object just got birth on the heap, that is a subscriber object. What does that subscriber object internally have? It has age, it has name and it has MDN. Right now all these values are null. Age is 0, MDN is 0 and name is blank or null. But that memory for age, name and MDN has been allocated. Where is this memory? On the heap. How much is this memory? That depends on the size of age, name and MDN. Age being byte will be 8 bits or 1 byte. MDN being long will be 8 bytes. Name will have a reference because it's of type string. And another very interesting thing is happening. S, which was so far null, the value of S was null. Now it won't be null because we are saying new subscriber. When you create a subscriber object, it returns, the new operator returns the address of the object which is created on the heap. So what will S have now? S is having the address of this object. Well, will Java tell us what is this address? No, it will just say S, the memory location S on the stack has an address. Where does that address point to? The address points to a location on the heap. What is there at that location? A subscriber object. How big is the subscriber object? It is big enough to hold the state of the subscriber. What is the state of the subscriber? The age, the name, and the MDN. These are the state of the subscriber. Now, using this S, I can do anything with that subscriber object. Anything I want to do with the subscriber object, I can invoke using S. S is actually going to be used to as a handle to the subscriber object. In many languages, we call S as a handle to the subscriber object. Just to make it complete, we are just going to do a very simple operation using S. So we are going to say S dot make call. Now, make call, as we saw a few minutes earlier, is a method available in the subscriber class. What is S? S is a reference. S is a pointer to a subscriber object. How did it become a pointer to the subscriber object? Because of these two lines, 5 and 6. In line 5, we said S is capable of holding a reference or an address to a subscriber object. But at that point, though we said it is capable of holding an object, S had a value null just a few minutes ago. The moment line 6 executed successfully, what happened? An object got created on the heap, that is a subscriber object, and a reference to that subscriber object is available on the stack. The value of S now contains an address of the subscriber object. But do I see the address? No. How do I go to the object? Using S. So when I say S.makeCall, it says go to the object pointed to by S, and on that object, that is this object, invoke an operation called makeCall, since it's already defined. So let's see what this outcome is going to be. Okay, so we finish the main. So this is what is happening in main. The main method will be automatically looked for by the JVM. It will enter the main method, and remember, at the cost of repeating, main method should have the appropriate modifiers and the appropriate signature. Then only we will be able to get this code to execute, 567 to execute. So let's do that once and see whether we are successfully able to do it. So we'll again do JAVAC on test subscriber. Remember, we already have done JAVAC on subscriber. Okay, so we get some kind of error at line 6, which is not able to find subscriber class. Okay, let's see why that error is coming. So at this stage, we have two classes. We have subscriber.java, which is needed by test subscriber. Why is it needed? Because test subscriber is instantiating subscriber. So it needs, besides test subscriber, it needs subscriber. Now let's try. We have already successfully compiled subscriber.java. But now we're going to see an interesting problem when we try to compile test subscriber. Because test subscriber has a dependent class or has a dependency that it needs subscriber class. Without a subscriber class, test subscriber don't work. Now let's see what kind of error we get when we try to compile test subscriber by itself. So we say JAVAC test subscriber dot Java. Okay, we get an error. Now if you look at that error, the error is coming on line 5 and also on line 6. The reason for that is both on line 5 and line 6, our program in test subscriber is using or is referring to a class subscriber, and the compiler is giving an error that I am not able to find class subscriber. Now you may wonder, why is it not able to find class subscriber? Is because though it is there in the same directory. Remember, our oops class directory, if you do ls minus l at this stage, can we do ls minus l? Yeah. And we see there is subscriber.class in this directory. There is obviously subscriber.java, and the test subscriber.class, actually it got created in an earlier case. It won't get created. So test subscriber.java. Now we clear the screen. So though we are having subscriber.class in the same directory, we are not able to compile it because there is the test subscriber.java is not able to find the subscriber class. In order to solve the problem, we have to set a variable called CP. CP stands for class path. Either you can say class path or you can say CP. Now look at the new line that we are doing. So we are saying JAVAC test subscriber.java, like we did earlier, but we are saying minus CP, that's an option to the JAVAC compiler, minus CP, we are saying dot. Now, here is something interesting which is happening. Earlier, if we just said JAVAC test subscriber.java, it did not work because it didn't find the subscriber class. Why it didn't find the subscriber class? Because your Java compiler looks for a path variable called class path. It looks for a class path is a set of directories which the JAVAC looks for or JAVAC searches for to find the classes it depends on. Like test subscriber was depending on a class subscriber. It didn't find it though it was in the current directory because we had not set a variable called class path. If you work on a Windows environment, the class path is automatically set during installation. But when we are working on a cloud, the class path may not be set and is not set as we just saw. So what did we do now? We added a couple of options here. We added one option actually, minus CP. Minus CP stands for an option to the JAVAC tool saying, Mr. JAVAC, the class path which you are going to look for is dot. Dot means current directory. In all Unix, Linux environment, dot refers to the current directory. So we are setting, using the minus CP dot, we are saying for this JAVAC command invocation, the class path is going to be also the current directory. So whenever you are looking for classes, look for the classes in the current directory. Because it was not set, the JAVAC didn't know where to look for subscriber.class. Now, when we say minus CP, that is class path dot, we are saying look for the dependent classes in the current directory. Dot stands for current directory. Minus CP stands for class path. We are setting the class path as current directory. So when now JAVAC is going to compile test subscriber.java, it is not going to say I am not going to find subscriber because subscriber is there in the current directory and I have set the class path to look for the current directory. So let's see what happens. Now we did not get an error because there was the test subscriber.java compilation which JAVAC did, I found it. Now let's quickly execute it and invoke the virtual machine on the test subscriber and we'll get that dummy thing called make call call. Okay, that's all. The make call call, that's the message we got. Okay, so this we have executed the first Java program. Now before we go deeper into this class, which is what I will do in my next session, my suggestion will be please come up to this point and then we will start working with this in our next session. Thank you.